Okay, good morning, class.
Morning, sir.
Yeah. Dominic, you can go ahead and share your screen. Let me see what errors you're having. Dominic, you there?
Yes, sir, I'm here. I'm just trying to get closer to the routers. The internet is a little bad. Just give me a minute.
Okay.
Sorry, I'm not being allowed to share the screen.
Oh, I need to. Okay. Is it saying that you're not allowed, or is it not loading?
It's now allowing me to do so.
You can try now. Okay, yeah, what's the problem?
Well, it's not allowing me to, well, the display is not lighting up or printing, and also the code from the temperature, the value from the temperature is not correct.
Okay,
Run the
all right.
simulation.
Yeah, start simulation. Okay, so here, okay, let me just check the circuit real quick. Okay, all right, stop the simulation. Click on your potentiometer. What is that? Okay, change it to 10K. Let's see. Yeah, that's good. Good. I still need to check some other stuff. Right. Let me see. Okay, click on the ground line for your potentiometer. Let me see as well. The black line, yeah, the black. Okay, good. That's fine as well. Right. So make sure your potentiometer is turned all the way down. Yeah. Actually, can you just share the code? Just go to share and send me the link. Yeah. So your backlight isn't lighting for some reason. Oh. Try switching your backlight LEDs. The two LED on like the two last pins on your LCD screen. Try switching them. For the backlight LED. So there's a resistor in your circuit and the resistors connect two LED pins, right? Yeah, those two LED pins. Just try swapping the leads. Yeah. Put that one over there and this one over here. No, that one needs to go to the resistor, right? You know, you're connecting it to two things there. Aren't you connecting it to... Okay, delete all the lines. Delete all the lines. All right, yeah, run it like that. Let's see. Your wires are mixed up somewhere. Oh, okay. I see. I see. Nine. Okay, switch them back. You got off. Did you stop sharing your screen?
The internet is bad, so it's going and coming.
Okay,
however, I can send you the
yeah,
link.
send me the link and I'll look at it. That'll be easier. Let me go ahead and share my screen.
Thank you.
All right. So today we're just gonna continue on, right, from Monday's class, and we're gonna try and do control the contrast with PWM. All right, and then we're gonna try and make text scroll across the screen. All right. Let me just give you guys some examples. So this here is text moving across the screen. So opposed to just printing some text out, right? We want to scroll across the screen, some kind of animation, right? As well as we want to control the contrast of the screen with PWM, right? So here I have some analog right function. And as I change the PWM value, remember this would be from 0 to 255. Change it to something like 80, right? See, the contrast is lower, right? The text isn't as bright. So I'm changing back to 0. It's nice and clear now, right? So while we wait on Dominic to send the link, we can do that. Okay. So remember, the contrast is controlled. You guys can see the screen, right?
Yes, sir.
Okay, good. So remember that the contrast is controlled via some signal. So from the previous circuit, via some voltage signal that came from this potentiometer. We know the potentiometer has 3 terminals, and they establish a voltage divider circuit. And based on the value of that voltage divider circuit, the voltage coming into this pin, right, this VO contrast pin, varies. Okay, now we want to know what different voltages, how do these different voltages affect the contrast? Well, to do that, we can just use a power supply, right? And we know power coming from the Arduino is 5 volts, and this potentiometer varies at 5 volts, right? Maybe somewhere from 0 to 5 volts. So you want to know what voltage range does this input pin collect, and how does that really affect the contrast. So let's just go ahead and just send some voltages straight into this thing, into this pin, right? So we can connect up here to the contrast pin. And this here, we can just tie it into the ground for everything else. Okay, good. And click start stimulation. And we see, we can't see anything, but as we lower the 5 volts down, let's lower it. 3, still can't see anything. Right, keep lowering. 1.5, we kind of start seeing something here. I don't know how clearly you guys can see it on your end, right? And as you move it down, maybe all the way to 0, we see it showing up nice and clear. So for the contrast to be highest, the voltage needs to be 0. Let me get my pen. So for the contrast to be highest, the voltage needs to be 0. For it to be lowest, it needs to be somewhere above like 2 volts, right? So it varies from, with a signal, from 0 to 2 volts. Right, some signal from 0 to 2 volts. And contrast, high contrast at 0 volts, high contrast, right? More clear. Low contrast, right? Low contrast at 2 volts. So this is how it varies, right? This is how it varies. So now if we connect up a PWM signal, right? Remember PWM would alter the duty cycle of that signal, right? Being on for a little bit and off for a little bit. Okay. Now, this here, on average, would correspond to a lower voltage, right? If we were able to somehow average this out, right? Something like 50% of 5 volts is approximately 2.5 volts, right? Duty cycle, if we were able to average it out. Now, a component that we can use to average this signal out is a capacitor, right? Because we know a capacitor is going to charge and discharge based on whether or not the potential difference across it is established positive sign on this side, negative sign, or when it drops to 0, he's going to try and discharge to help maintain this charge here at that level. So it's going to store up this extra charge here at the top here, right? And then release it back when it drops down low, right? That's just how a capacitor works in a DC circuit, right? So we can use the capacitor along with the PWM to establish this voltage signal that we want. And we want this voltage signal to vary somewhere between 0 and 2 volts. Okay. So let's put the capacitor back. Stop the stimulation first. We can go ahead and get rid of this power supply. Okay. Then we can drop this back here. So these two are gonna connect up to the PWM pin, right? PWM 9. And we're gonna put the capacitor to help smooth out that waveform, right? Smooth out that waveform. And we can put the scope to see how that smoothing is done. Right? Negative ring is tied up to the same ground as a reference. And we can take a look at that signal, see how it's moving, right? So here's some PWM value. Of course, we're gonna have to write that into our code. So I'll go over that part just now. And the negative terminal of the capacitor is set to ground, right? And this part here is just connected in between along the way from the PWM pin to the voltage signal in pin, the contrast signal pin, right? To help smooth that signal out. Okay, good. So start. We see here, I'm gonna have to stop it and start it back. Right, so start. We see these initial transients, right? But as it progresses, we see a steady voltage, right? Steady voltage. Now, according to this scope, that voltage is just a few millivolts. So pretty close to zero. Right, and we have our analog contrast control set to zero. So if we put it something like maybe, let's say 100, start simulation. We don't see anything. We see our initial transients and we see our waveform kind of holding still, right? And if we were to adjust the scale a little bit, maybe to 500 microseconds, we see the charge and discharge, charge and this charge wave of the capacitor, right? Charging and discharging, but still on a lower resolution, that essentially looks to the pin like a straight waveform. Okay? And as we lower that, it does the same thing at different values. It's just that how much it controls shifts and varies according to the voltages. So you might get more transients, a bit noise, because it's harder to hold those different voltages in place, right? Yeah. So that's it basically, nothing much to it. And of course you need to write it into your code as well, right? You need to set up some pin for it. You can use a variable if you want, and you need to set that as an output. So you can just do, here we connected it up to pin 9. So we can just do pin 9, right? Output analog write, pin 9, and then you write that value. Of course, you don't want the value to be 100. You want it to be within that 0 to 2 volt range. So you're gonna have to go a bit lower. Something like 50 is a good value, right? And of course, these here, I replace them with variables, right? Contrast control in case I ever wanted to switch to another pin, right? So that its code is modular. Okay, then just start simulation and you see the contrast is at that level. You want to change it, you can just put it to 0 so that it's at its max, right? And it's nice and bright. Good. Now, any questions on just how you would implement this? Remember the potentiometer. We're not using the potentiometer anymore, so you can just go ahead and throw this away, right? Connect the pin 9 to the positive end of the capacitor and then into the voltage signal in, right? That third pin on the LCD, and then connect the negative end up to ground, right? In the real world, for the capacitor, it usually has a slightly longer lead for the positive end, right? This end is usually slightly longer for these polarized capacitors. This lead is slightly longer and this one shorter. There's also this strip, this white strip to denote the negative side. Right. So let's take a different one again. Like let's say this one. Yeah, this white strip here would denote that this end is the negative end, right? So just keep that in mind. For ones like these, you know, if you can see which one is slightly longer, this one here is positive, right? Positive. And the side with the white strip is negative. Okay. And here, even in the simulation, they have like the little white strip there, denoting that that side is negative. Right. So that's how you connect it up. So just take your code from yesterday, modify it a little bit. Right? Put this capacitor in and add in these two lines. Right? The pin mode, contrast control output, contrast control 0. But remember, this contrast control refers to a variable which has the value 9. So you can just go ahead and put that pin right in there. You don't need to put this variable in there, right? You can just go ahead and put that pin number 9. So give this a try and let me know if you have any problems or you need some any assistance. All right. Any questions though?
No, sir.
Good, go ahead. And Dominic, you can send me the link to your code.
I did, sir. Send it in the chat, Zoom chat.
You sent it in the chat.
Yes.
I don't see it.
Dominic, you sent it to me in direct message. You got to change it to sir.
My bad.
All right, good.
Yes, sir. Just resent it.
Sir, you can switch back to the circuit real quick. Thank you, sir.
Okay, Dominic, so made a few changes. So one of them was setting the cursor to this second row in the first column so that when we print the message, it prints there. Right? I put a space here between the C that you have there, right? This C, so that it's one space away from the temperature, right? Okay, good. Also, yeah, I think that's what it is. And the fixture LED, right? I just changed the value of the resistor, put a more reasonable value, about 300 ohms, right? Of course, this is something that you would want to check with the data sheet of this LCD display to figure out what value is good. Usually a 1K resistor is fine, or like a 500 ohm resistor is fine. All right, that, and I think, I don't know if maybe one of the wires are crossed causing it to be too dim, but I think it's just the value. I just lowered the resistance value a little bit. All right, yeah, and that's it. It's good now. All right, good. Any questions on it?
No, I think that was because yesterday I was playing around with the resistor value. The lowest I went was 500. I didn't get any change. Even
And it
wired
didn't
it, and I
change
still
in
didn't
terms of
get any
brightness.
change. But
Okay, so look at there right now. I see it changes, right? Let's say 1200, right? Like from 1200 to that, it gets brighter, right? Yeah. All right, good. But if you were changing values and it wasn't getting any brighter, maybe your wires were crossed somewhere. Like I think this one was down here. I wasn't too sure. Yeah, something like that. This one was down.
I think, yeah,
So I put it
that
up.
was the exact problem. And that wire was in the positive side.
Yeah, so we need to do is just connect it both up to like 5 volts and ground. In like
All right, thank you.
in a lab or something, you'd have to put a resistor in place, right? Because you don't want damage this board. I'd be connected up to 5 volts and then switch, right? Switch and see which side lights up, and then okay, put that hit there and that there, right? Okay, good.
Understood.
Okay, so did everyone get the PWM working?
Sir, can you switch back to the circuit?
You have an issue?
No, sir. I didn't get to put in the capacitor.
Well, go ahead. Did anyone get the capacitor working? The capacitor and the PWM working?
Sir, what's the rating of the capacitor?
What's the what? The rating?
Yes, sir.
You can just put it to about 5 volts, right? 5, 6, 7 volts. The rating shouldn't affect it unless it's like lower than 5 volts and you send a really high PWM value in here, right? But just keep it reasonable. The value of the capacitor is just 100 microfarads, right? And you can play around. It doesn't need to be exactly this, right? You can play around with that value. That's the purpose of simulation, right? Play around, see which values work best. Or you can go the other way and do some calculations, right? See which values would give you the best waveform. Yeah. So realistically, how you would do this in a simulation, you would of course drag out your scope, right? Connect up, try different values of your capacitor, right? To see which one gives you the best waveform. Then you'd select that, right? Or as I said, you can go and do the calculations if you want. And nobody really got time to do calculations like those.
Sir, can you please go back to the code?
And these 2 lines are the only 2 lines you're adding in, right? Everything else is the same.
All right, sir. Thanks.
Everything else is the same from before, right? As long as your code was working before, right? You don't need to change it. You just need to add in these 2 lines, right? And remember, contrast control needs to be 9, or you can create the variable contrast control. Okay. Create the variable like int contrast control equal 9. And this 9 refers to the pin. The pin here, pin number 9, the PWM pin that we're using.
Sir, I'm having some problem with my code.
Okay, just share your screen. Okay, okay, close that. Not the code, the red window. Yeah, replace contrast control with 9 with the number 9. Delete the entire word and put the number 9. Yeah, good. And again in line 22 as well. Yeah, remember, if you haven't declared the variable contrast control, you can't use it, right? Yeah, now start simulation. No, your capacitor rating needs to be changed. Put 100 microfarads. Wait, how is it set up? Oh, okay. Yeah, put it 100 micro, not millifarads, micro, right? Micro. Okay, good. No, you put the negative end to 5 volts, right? You see that red wire coming down from your capacitor? That needs to go to ground. Right, that needs to go to ground. So it goes from ground into that. So click at the bottom of it and move it up to 1 space. No, at the bottom, move it up 1 space. No, click on the bottom. Yeah, move it up 1 space. Put it to ground. Yes, good. Good. Now your signal wire needs to be connected to that green wire, right? So you move it across 1 space. No. The other wire, the signal wire, the pink one. Yeah, move that across 1 space. All right. No, to your right. To your right, to the other way. Yeah, okay, good. Great. Okay, the red wire, we moved the red wire as well. So you gotta move the red wire back. Delete the entire red wire. Okay, delete the entire red wire and the pink wire, delete both. Just delete both, okay? Are you hearing? Delete. Just press delete.
Stop sharing, I'll come back again.
Okay, is your screen frozen? Did everyone else finish? Because we have more work to do. We have the scrolling text that we need to do as well. Did everyone else finish? Dominic, Michael, Antonio, did you guys finish the PWM with the capacitor and got it working?
Sorry, I'm trying to figure out why I get some error on the codes. I don't know if there's a value I can paste or something is out of context.
Okay, just send me the
So-
link. Just send me the link in the chat instead of me trying to tell you guys what to do.
I'm sorry, I got it working, sir. Thanks.
Well, then are good. Great.
Just send the link. Sir.
Open it up. All right, from 9 to capacitor to signal, great. Capacitor to ground, great. What's this doing there? Okay, leave it there. Ah, equal sign, right? Equal. Yeah, that should be it. Change this to 8. Okay, good. Right, and then you can go ahead and change this value to 50 0 and see how it changes there, right?
All right, so thank you.
This red wire isn't doing anything, so let's go ahead and delete that. It's probably there from the potentiometer. Okay, good. So that's all you kind of have to change. Change this from a minus sign to equal sign. And then just turn this down a little bit. Right, so it's any value from like 0 to about 80 should be fine. Okay, anyone else have any issues?
Oh, sir.
No. Okay, good. So, okay, so I want you guys to open up a new, just go to Tinkercad. So no one's worrying about the circuit anymore. Just create a new circuit, right? Click create a new circuit. That should open up this thing. Come here, just type LCD, scroll down, right? And pull this starter out. Okay? With this starter, you have everything already connected up for you. So you really don't need to worry and you can focus on the code, right? You don't need to worry about all the connections, right? Okay, so do that on a fresh program because we want a potentiometer now back. And let's just focus on the code. So for the code for this one, after you finish dragging out, create a new circuit, drag out your stuff, right? Then you start writing code. Okay, good. So the first line of code is to include that same liquid crystal library, right? That header file. It has all the cool functions we want to use, like LCD begin to set up that object, well, to set up the dimensions of the LCD, liquid crystal to create the object LCD that has certain properties and methods associated with them, right? Okay, so that's the first line. These variables here, LCD column and LCD row, are the dimensions of the LCD, right? Then we have some other variables in first, in last, in the row, in column. And the thing is with scrolling text, let me run the simulation. For the text to be scrolling across the screen, we don't want these fixed dimensions here, right? We want modular dimensions. That's why we have row and column, right? Because the column is constantly changing, right? So we want a variable that we can modify because the column's always changing, right? Good. And then we want the string, right? A variable that's a string type that's going to store the information we want to print. So we don't want to print hello world anymore. We want to print something longer. So you can put any phrase here you want, right? We want to print something longer and we want to make it scroll across the screen. Okay. So now let's just say we wanted to, again, just print hello world. How do we go about doing that? Well, first we'd create the liquid crystal object, right? And set up our pins, right? Remember, we're only using 4 pins, not 8 pins. If we were using 8 pins, we'd have to initialize the other pins here, right? But we're only using 4 pins, right? And they're connected on an Arduino board. The pins 4, 5, 4, 3, and 2. And the register select and enable pins are connected to pins 12 and 11, right? So we create our LCD object connected up there. As always, this can be anything. This can be LCD 1, 2, 3, 4, 5, or any other thing you want to name it, right? It's just an object. It's kind of like a fancy variable, right? The object is this thing that is encapsulated with certain properties and methods, right? All sorts of variables and functions associated with them, right? As I was saying, an object is kind of like a car, where the car has a color, a brand, right? And they have certain functions, certain things you can do with the car, like drive or accelerate, decelerate, right? Brake, all kinds of things, take you somewhere, right? Different functions associated with the car. The car is kind of like an object, right? So instead of having something like int var equal x, we have liquid crystal LCD creates LCD, which is kind of like var, and liquid crystal is kind of like that keyword, right? That keyword that says this LCD is like a fancy variable and object, an object that's going to have certain properties and functions associated with them. So that's why we can do things like LCD begin, and that's like saying let's say we had something, going back to the car analogy, we'd say like we'd have something like make car, something like liquid crystal, make car, car one, and then we do car one dot color, and we'd say blue, right? And what that does is it finds the color variable inside the object, right? And it stores the color blue inside, so that when the functions, the different methods need that variable, they can access it and say, oh, this car is blue. So maybe blue car is not supposed to drive too fast, or blue cars have some kind of intrinsic feature, right? Associated with them. And again, this is just an example. So when we create this LCD object, right, we can use it like this. We do LCD.begin, right? I remember this could be LCD 2, 3, 4, 5, anything you want it to be. Dot begin, and we're saying, okay, inside that, find the column and the rows and stick these two variables in, right? These two variables are going to represent the size, the number of columns, and the number of rows inside this LCD. We're defining the LCD dimensions. Okay, good. So if you wanted to print text like hello world, we of course define the dimensions, right? Then we set the cursor someplace, and then we just do LCD print hello world, and that's it. That would be the end of it, right? But now we don't want to do that, right? We want we want to print the code in a very unique way. We want to print the text in a very unique way. Let's see how small I can make this. Okay. So first we would want to print something like T, then we'd want to wait a little bit, right? Then we'd want to print something like TH, wait a little bit, print something like TE. Let me try drawing that out. So we want the text to scroll across, right? We have this long sentence, the black bird, whatever really long phrases. But in the context of our LCD, right? Remember there's 16 columns, right? 16 columns in each row, right? So for this text to scroll across, we just want to print some substring of this T, right? So we want to print T first, and then we might want to wait a little bit, maybe half a second or something. So 500, we delay 500 milliseconds, or maybe delay something shorter, 250. Personal preference thing, right? How long you want delay. So you print something like you print T, right? Then you delay, and then you'd want to print TH, right? So that it looks as if it's scrolling across, and then THE, right? THE, and then THE space, and then THEB, right? So that it looks as if it's scrolling across. So now we need to write code that does that. Now, first of all, with this text, we want to pull out different parts of it so that it prints, right? We want to pull out the T alone, right? And we want to pull out TH alone. Then we want to pull out THE alone. And we want to pull out THE space, THEB, and so on and so forth. So we need code to do that. So what we can do is we can write a function that does that, or we can realize that texts in Arduino are objects as well, and they have this particular method associated with them, right? That method is called a substring method. So substring, and remember, anything you don't know in Arduino, you can always just check the Arduino reference. Substring is a function / method because associated with text, right? And what it does is it pulls out a substring from the string. So our string here would be blackbird. And if you were to do blackbird dot substring, right? And of course, this here needs to be encapsulated as a variable, right? Right? Some variable I call my text dot substring, right? And then we put in some parameters. It tells the substring method, okay, I want this part of the string or that part of the string. And the way it does that is by taking two parameters. Let's say the first parameter, first, and the last, right? You can think of this as taking two numbers, 0 and 1. Okay, now the first parameter tells us where to start taking in, right? So you remember a string. Let's pretend this here is a string, right? The first slot's gonna have T, second slot H, second slot E, second slot space, second slot B, right? And so on and so forth, right? So here is index as 0, 1, 2, 3, right? Remember a string is just an array of characters. So just pretend this is an array of characters. So T is the first part, is the first character in this character array, and it's indexed as 0, right? 0, 1, 2, 3, 4, so on and so forth. So if we give this substring function, right, 0 is going to say, okay, start taking from T and then go all the way up to, let's put a different number than 1, 2. Go all the way up to 2 here, right? and classify that as a substring, and that's what we want you to print. Now, the thing is, the substring function doesn't do it exactly like that. It does go from 0 and it pulls out that T, and it does go all the way to 2 and pulls out letters. But the index 2 is not inclusive. So the letter E isn't included in the substring. The substring would actually just be TH, right? So let's say, let me make some space. It's getting a bit confusing here. Draw this back. So T, H, E, space, B, L. 0, 1, 2, 3, 4, 5. Let's call this number here 5. Right, substring 0, 5. So it's going to come to 0, or let's modify it a little bit. Let's say substring 1 to 5, right? So that we can talk about both. So this first one is inclusive, right? Inclusive. And this one here is exclusive. So for this one, it's going to go to 1 here, and it's going to collect H, right? And then it's going to go all the way to 5, and it's going to collect letters, right? So it's like H, E, space, B, right? But at 5, remember 5 is exclusive, right? Non-inclusive. That's probably a better word, non-inclusive. Non-inclusive. So it's not going to include the letter stored in the 5th index of this character array, right? L is not going to be included, but H is, because this first one is inclusive and this one is non-inclusive or exclusive, right? So that's the substring function, right? Or the substring method. It takes a substring from the text, from the string, from the first index to the second index, but the second index or the ending index is omitted, right? And you can go and read all about this function if you want, right? Okay. Now back to our code. Now, if we want to print this code, remember I said we wanted to print. We wanted to print T, then we want to slide it down and print TH. Then we want to slide it down and print THE. So we're doing two things. We're moving the cursor constantly, right, down this way. And we're printing different substrings, right? We're printing different substrings, and then we're going to move the cursor down again. Then we're going to print another substring. Then we're going to move the cursor down again, right? And then we're going to keep printing, so on and so forth, right? So we obviously need some kind of incrementation going on with this substring. So first, let's look at this line number 36, lcd.print. So we're printing something. What we're printing is a substring of text. Now remember, text is that variable from up here, which we stored our text in, right? String equal text, right? And this is its long sentence, right? The quick brown fox jumps over the lazy dog, contains every letter of the alphabet. Right? You can put whatever string you want to put in. Right? So text.substring, it takes a substring of that text. And that substring is based on these two variables, first and last, right? Now, here, the last, we want it to be incremented, right? So you want to print here, here's going to be 0 still, 0, 0, 0, 0, 0, 0, 0, right? Up to 1, remember 1 is going to refer to H, but it's not inclusive, right? It's omitted. Then we want to do 1, 3, 4, 5, and we want to increment, so on and so forth, creating different substrings, right? So this last here, we're going to want to increment it, right? So last equal last plus 1, or you can just write last plus. Either one is fine, right? Or even more, we can write plus equal 1, which is something you might want to do as well, right? However you feel like doing it. Okay, so we're having last in there and we're incrementing it, right? Okay, good. Now here we can see last starts at 0 and it's incrementing, right? So it's going to increment and it's going to print. Now, we obviously need to change the column, right? We want to change the column. So the column, we want it to constantly be moving, right? Now that column is going to be based on last. So as last increases, the column should decrease, right? So column, remember we're going to be printing till over here, right? At column 16, this 16 column, right? 16 column. And as T, as last increases, right? We're going to want to print down here, right? We're going to want to print the 15th, the 14th, the 13th, so on and so forth. So we can do 16 minus last for the value of column, right? Which is what we have here. Now, of course, we need to think about other things, right? 16 minus last is the column value, and that'll print and that'll go about, and last is incrementing. Now, another problem would also come about. Let's run the simulation. Right? Let's remove this debugging thing. Okay, so it's printing th. Now here, the H is gone, the Q is gone, the B is gone, right? So the first index of the substring is now changing, right? So we need some way to change that first index of the substring, right? And that's what all this other code is about. And we need to go through that line by line, of course, right? So there's this part here, and this affects the first index of that substring. So if last is less than 17, then first is equal to 0, right? So if last is less than 17, then first equals 0, right? And that's the amount of text that will fill up here, right? 16 columns, 16 slots for 16 letters, right? So first will be 0 for all of that, right? So start. First is 0, first is 0, first is 0, first is 0, first is 0. After that, it's first is not 0, right? So if it's that, first is 0. If it's not, if it's greater than 17, or if it's 17 and greater, right? Then first is equal to last minus 16, right? So when first is 17, when last is 17, first is going to be 17 minus 16, which is 1, right? So it's going to move from being 0 to 1, right? And then to 3 as it increments, right? 3, 4, 5, 6, and so on and so forth. Right? We're going to subtract 16 from the value of last. Because remember, the value of last keeps getting bigger, right? Keeps getting bigger as we go through this string, right? Last keeps getting bigger, going through. So last, we just keep subtracting from that. And as last increases, first kind of gets dragged down, but it waits until 16 letters, 16 characters have passed. Okay, it Okay, good. Now, the thing is also, which is this little piece, this little line of code here as well, is that the column here, let me stop the simulation second. So the column here is constantly changing, constantly changing, constantly changing, right? But after here, the column doesn't need to keep changing, right? Because we're sending in the substrings, right? Because first is changing and last is changing, but we're still printing from this first column. So this line, if last is greater than 16, then just leave column as 0, right? If it's less than 16, like at the start of the program, then do the subtraction and change the rows, right? So all of this, it kind of makes sense. Now, okay, good. Now, additionally, we want it to reset, right? We want everything to reset back, right? So if last is greater than the length of the text plus 15, right? So start the simulation, let the text run out. It's gonna run out and it's gonna finish. And that last letter is gonna be trailing, right? That last letter is gonna be trailing. It's a really long sentence, okay? But essentially what this does is it when that last letter dips off the end, reset last back to 1 so that we can start printing all over again, right? See that? After the full stop, it starts printing all over again. And that's what this line does. Okay? Now I know there's a lot going on in this code, right? And there is the additional addition of this space, which is just a buffer to keep our text clean, right? As we print and refer to different things. It could be used in a way where when we print text, the full stop doesn't run into the T, right? When we print, but in this case, it doesn't. But so it's just really used as a buffer to keep our code a bit clean and keep things that we're referring to clean. All right, good. So overall, any questions on this program from start to finish?
Sir, when I type, I don't have any at the moment.
Okay, when you type it up. All right, good. So again, remember, don't build the circuit back and try to put back the potentiometer because I don't want you guys get too much problems, right? And then we have to fix all the problems with the wiring of your circuit, right? So just go ahead and start typing up the code. Remember, this code is also in the textbook, right? Also in the textbook right here. But you gotta modify certain things, right? So if you're gonna copy the code from text, you need to modify certain things. Things that you need to modify is the row, right? And these pins for your liquid crystal display, right? These pins, right? So you need to modify those. So keep that in mind if you're copying the code from the textbook. Very good. So this is it. Remember, just drag out the starter, create a new circuit, drag out the starter, LCD starter, so that you don't have to waste time wiring up everything and you can focus on your code. All right, good. So give this a shot. And if you guys have any issues, let me know. Any questions, let me know.
Sir, can you scroll down? Please, thank you.
sir, when we get through, we can leave, or you have something else to do?
No, when you guys finish, you can leave. Did you guys get it working?
Sir, I think I'm
Yeah,
having
sir, mine's working.
Okay, good.
sir, I think I'm having error with my code.
All right, so just go share and send me the link. Right, invite people and send the link. How about you, Vlad? You still working?
No, sir. Finish.
Okay, good. So just will then send me the code and I'll take a look at it.
No, sir. I said I get through that. I'm finished with it.
Oh, yeah, I know. So it's just will then, right?
Oh, okay.
So this is will then. Good circuit, start simulation. Code. Okay. Yeah, hashtag include. Void setup. Yeah. Semicolon. Uh, column equals 0. What is this? I don't have that. Okay, so void setup there. Void loop there. Close curly brackets. Okay, well, it's printing. It's just not printing the right thing. Stop stimulation. Let's take last +1. What's this doing there? So you had a semicolon here. So what happens is that when the semicolon is
Line
there,
22.
then line 23 doesn't execute if it executes all the time, right? So remember this second line is based on this first line. So we only wanted to execute if this was true, right? But when you have it here, right, it's not executing this line, right? So we usually don't have semicolons after the if loop.
The
If you can,
iteration.
yeah, you can put this up in this line if you want as well. There are many different ways, so you need to review if loops, right? So start simulation. And it's running now. All right,
So
good.
that was the problem with it, the semicolon.
Yeah, and
Okay, thank you.
some other minor issues here. You had L, it includes semicolon there, right? L, you spelled this wrong. Semicolon there. You had an extra line at the bottom. Just a lot of minor issues.
So you could send me back the link so I can.
No, it should change automatically, right?
Yeah.
So reload, and it should change automatically, right? So you guys can go home now.